So, my name is Swaminathan Vetri. You can call me Swami. And I work as an architect at Maersk. I have a brief, detailed introduction about myself. So, the session today I'm going to talk about is on the DevOps practices for large distributed teams. All right. Yeah, that's a brief introduction about myself. Like I said, my name is Swami. So, I have two little daughters who keeps me occupied other than work and things. And I work as a cloud solution architect at Maersk. How many of you have heard about Maersk? Before I continue with the introduction, did anyone attend my previous session yesterday? So initial 5 minutes, you might find it repetitive, okay? Please don't give any clues to your neighbors, right? So yeah, I work as a solution architect at Maersk. So Maersk is a company that ships containers across the world. And they ship physical containers, and I work on the software containers that helps in shipping the physical containers. How cool is that, right? Yeah, so as my day job, I'm focusing on architecting solutions on Azure, using Azure PaaS services. And we are building microservices on Kubernetes. We use AKS, and then we use all the DevOps practices, which is what we're going to talk in detail in this session, right? And I'm also Microsoft MVP under Developer Technologies since 2016. It's been 7 years since I've been part of the community events and other things. And I'm also a member of .NET Foundation. I used to be a .NET developer from the beginning of my career. I still have touch on my .NET, but mostly now I'm focusing more on the architecture side. And those are my social handles, GitHub and Twitter. And I also started a YouTube channel, like yet another person during the pandemic, right? Sitting at home, not knowing what to do, just start a YouTube channel. So just there. And yeah, apart from these, I also have a blog, and photography, traveling are some of my other interests. So the agenda. So let's start with the basic understanding of what is DevOps. So just to get a hang of the audience, how many of you are already using DevOps? Okay. How many of you have a title DevOps in your title? DevOps engineer, DevOps architects? Quite a few? Okay. Developers? Okay, only few developers. IT, ops, admins? Great. Okay, sure. So initial few minutes we'll spend to level set everyone on what is DevOps, and then we'll see basically what is DevOps. And then we'll look at how we kind of try to accelerating our journey from planning to the coding. And then we'll also look at how we did deployment releases and continuous monitoring and feedback. And finally, I'll also share some of the things like what didn't work really for us, because that's also more important, right? And then we'll see how we are planning to move ahead from here, right? All right, so what is DevOps? This is not an interview question, so anyone with the DevOps title or without the title also can tell. What is DevOps? Sorry? Anyone? Developments plus operations, okay. That's like an abbreviation, okay. And then? So we always had a development team. We always had an operations team. They were all together in the same floor, sitting in the same office. So what's new with DevOps now? Sorry? Developer doing operations? Okay.
Developer combines with operations, and it is a process getting implemented.
Sorry?
It's a process that we introduce in an organization where developer and operations can work hand in hand,
okay,
and improvise the code, push or deployment process.
So it's like this hall, right? Initially it was all open. So dev sit here, ops sit here, but
yes,
now it's all split. Let's say if developers are sitting in this room, we don't know what the other guys are doing.
Correct.
We just pass something there, and then they do whatever, and it was like ping pong,
right,
which is what we want to address, right? Okay, that's good. So yeah, so overall if you look at it, so starting from planning, and then to development, delivering, operating, everything is in a loop, right? This is how the entire software development lifecycle works, right? So DevOps, as someone said, it's a compound of dev and ops for sure. And then this is one of the definitions there. You can find a lot of definitions on the internet, right? It's a union of people, process, and technology to continually provide value to customers, right? So what are some of the key things here? It involves 3 aspects, right? People, process, technology. So it's not just the technology or the tools that helps us. It's the people, which is the first thing. We all need to have that proper mindset, or the DevOps cultural mindset in our minds. Basically, only then we can start abiding to that processes, and then that process we can implement using technologies, right? So when we talk about planning, what are the things that comes into planning, right? It is ideation. Someone wants to say, I want to build an next level, whatever, ticketing engine or whatever. That's the ideation, right? And then you'll have to define your product, and then you'll have to again go into a backlog, creations, and agile methodology, whatever, Scrum, Kanban. Anyone using waterfall? Anyone using waterfall within Scrum? Huh? Everyone, right? Anyone using Kanban? Kanban? Cool, yeah. So these are some of the different methodologies which we can use to do our planning and then prioritizing the work, etc., right? So yeah, the key thing is when you talk about planning, it's all about ideation phase and then your product definition phase and creating your backlogs and then using or defining any of your processes, right? And next is your development phase. That's where code. I saw a few hands raised. Developers, you write code or copy paste code, right? So we write code. That's the coding phase, and then we do reviews. Any peer reviewers, code reviewers here? Yeah. So we do also do reviews and then automated testing. How many of you test? Are you a tester by profession? Any developers write tests? You write automated tests, unit tests? Excellent. So any automation testers like Selenium, any other stuff? So automation testing is also a part of your development cycle now, right? And then continuous integration. What does that mean? Continuously talk to somebody else. Hey, what code have you written? I have written the test. Is that what it is? Merging the code. Let's say in a bigger team, maybe 10 or 15 people will be working on it, and each one could work on different features. So how do you keep on integrating at a shorter cycle so that you don't really sit over the weekend to merge the code and then get things working, right? That's the develop part. And then the delivery is where you'll use continuous delivery or continuous deployment. You might have heard of something called CI and CD, which is what is continuous integration, continuous deployment here, right? So, okay, I've integrated it. Now, how do I ensure I am able to deploy it properly into an environment? Okay, that is where your CD comes into picture. And then once you deployed it, how reliable are your deployments, or how consistently are you able to deploy your components or your application, right? And how are you provisioning your infrastructure? Is anyone still waiting for infra requests to be processed? I placed it 2 weeks back. I'm still waiting for my ops team to come back. So, yeah, I'm on your boat, man. Same, yeah. See, if you're working an on-prem setup, for sure that still happens, right? It's not completely, how to say, as fast as what we get in the cloud. But in the cloud, the scene is completely different, right? You can automate everything. The moment if you think you want to create a VM, in the next 5 minutes you can automate it and then you can get the VM running. If you want to create a provisional database, you can just create it, right? But how do you create it in an automated fashion, a repeatable fashion? That's also part of your delivery. And then finally, the monitoring part, or the operations part here, right? That's where you have a continuous monitoring. So I put something out there, and then I just move on to next project. Is it what is expected from a developer? No, right? We also need to know how it's working really. Is it really giving the appropriate responses and the appropriate latency what we have agreed? Is it how much its availability, how much it's working, what kind of errors it is throwing, everything we need to monitor, right? That's where you'll do a continuous monitoring by capturing some of these telemetries. And if something goes wrong, we wait for someone to call up on the phone, right? Hey, you know what, you put something over the weekend and it broke, right? So we don't want to do that way. So we need to set up automated alerts and everything. That's where the operations part comes into picture. Capture the telemetry, create alerts, and then identify system availability, reliability, etc. So if you're trying to follow, I mean, all of these are part of your DevOps processes, right? So now, what's the culture? How does the DevOps culture look like? So collaboration, visibility, and alignment. Are you guys able to read this, or I'm hiding it? Is it okay? A little bit here? Okay, maybe I'll move here. Collaboration, visibility, and alignment is one of the important things. Like I said, let's say if I am sitting here in this room working on let's say I'm a .NET developer, we need to know that what is the .NET framework available in the server where I'm going to deploy it. I'll just start working on something, maybe .NET 5 or something, and I'll code it. But on the operations side, they would think maybe, you know what, a new version of .NET has come, so let me upgrade all my servers. If they do it, then when I try to deploy it, it's not going to work, right? So the collaboration is the key here. So whenever we start looking at, let's say the planning phase itself, right? The devs, ops, everyone need to sit together and then discuss what are individuals' roles and responsibilities, what is that the dev is going to do, what is that the ops side is going to do, what kind of readiness is needed from both the sides, right? Sit together, discuss, and then identify that. Identify it, provide the visibility to both, and then get an alignment, right? And once you have the alignment, next is around the shift in scope and accountability. So what we mean by this is performance. Okay, how many of you use performance or think about performance when you develop an application? Typically, it's an afterthought, right? First, let's get it working, right? Let it ship it, and then we'll see whether it is really performing or not, right? That's how typically we all kind of work together, right? So that's where the shift in the mindset is needed, right? So devs need not have to worry about after deployment what it is going to do, how it is going to work, right? While deployment, how can you bring in those performance practices? How can you at least put in some counters or whatever the data to be emitted so that you can capture your performance, right? So those things need to be done. That's why we call it shift in the scope. And also from the accountability perspective, let's say security. Security is also an afterthought, right? Nobody knows how the connection strings are maintained or where should be maintained, right? I'll just commit into the code, it just works, I'm happy, right? But that's not how it should be, right? We need to really securely place the connection strings or enabling any connectivity to your application, to databases, everything needs to be secured. Right? So these are some of the things the ops team can bring in early in the cycle and then help the developers understand, hey, you know what, are you going to connect to a database? Okay, so these are some of the security best practices which you can follow. Right? So have those conversations so that everything is kind of shifted. And then shorter release cycles. How many of you are releasing every day? Excellent. Monthly? When daily guys don't keep, again, raise your hands, okay? Monthly? Few guys? Okay. Yearly? At least everyone should release once in a year. If not, what are you guys doing then? Right? So I hope all of you understand the longer release cycles problems, right? The more you wait for your code to go into production, there are a lot of room for changes and a lot of churns can happen, and you can't isolate what is really breaking things, etc. Right? That's where it's imperative to have your release cycles in a much shorter way. So let's say every 2 weeks or every month, to start with, if you're releasing it, you can scope your items what are going to the release accordingly, and then you can try and minimize the impact as well. And also continuous learning. So like I said, after we push things into production, we really don't bother it. We just move on to another project because our managers have asked us to go into another project also, right? That should not be the case. So start looking at how things worked and then what didn't work, and then start improvising from there, right? Capture the performance data, capture the availability data, etc., etc. Keep monitoring it, and then look at how we can improvise the system, right? If we are trying to follow all of this, that's when we can say at least, yeah, we are having a DevOps culture in our thing, right? Has anyone been already following it? Yeah? Excellent. And then, so now what are the practices? Oops, how did it come? Yeah. So we talked about culture, we just talked about what is DevOps, we talked about the culture, and then how do I follow or imbibe that culture? There has to be some practices, right? So first thing is like using Agile software development, because that can help you in getting across all of those, right? You can have smaller sprints, you can have shorter releases, and then you can sit together, all of us can sit together and then plan, proper collaboration would be there, right? That's where we can use something called Agile. And next is version control. How many of you have seen applications working in production but not knowing where the code is? Have you guys faced this scenario? Especially people working on legacy systems or on-prem systems, right? It just works, but I don't know who coded it, how they coded it, where they maintain the source code, etc., right? That should not be the case at all, right? Anything you want to push into prod has to be version control. That's the first thing we all need to get into, right? Whatever is there, or if you don't have that code, reverse engineer it, get the code, and then push it into at least version control, right? And next thing is continuous integration, which we just talked about some time back. So keep integrating the multiple features and multiple individuals' code into the source control very frequently, and then ensure the builds are working fine, right? And then continuous deployment. So the moment you build it, there's no point in waiting it. So just keep deploying into the environment and then check how things are working fine there, right? And then infrastructure as code. That's something pretty new, right? Infrastructure as code. How many of you are already using infrastructure as code? What do you guys use? Terraform? Okay, excellent. Bicep? Excellent. You got my guys. Okay, and then? ARM templates, Bicep, Terraform, Pulumi. There are a number of tools available again there, right? So what do they do? Like I said, you can create infrastructure in a repeatable fashion, in an automated fashion. Right? You create the entire set of infrastructure as a code, and then you just keep running it, and then it keeps creating them again and again. And then configuration management. It's again, this can go hand in hand with each other. Like your configurations could be different. Let's say if you're working in a Kubernetes ecosystem also, right? You can have a lot of configurations available. So how do you, extract your configurations from your application-related stuff? Come up with the configuration management policies, etc. And finally, continuous monitoring, right? If you all of these comprises your DevOps practices, right? Now, we'll now start delving into what are the things which we've done and what are the things we have taken care, right? So just to give a context to everybody, like I kind of head a DevOps team, which is like we have around 7 to 8 member team, and we have a 100 member development team, right? So this is where we are trying to empower or enable them, right? And our architecture is like we are working on, as I said, cloud services or microservices which are deployed on cloud. So the deployment target is AKS, which is Kubernetes ecosystem, and then we use some of the Azure resources like Azure SQL DB, Azure Cosmos, etc., as a databases there, right? So our work starts from getting the entire thing. CI/CD is one part of it, right? But we also have other things that helped us in getting the entire journey fast. That's what we are going to talk about now. So like I said, since it's a distributed team, we had like 100 members and they were like 7, 8 Scrum teams. So each one of us, each team were assigned with a specific business functionality, right? They focus on their own microservices. Now, how do you bring in consistent practices about their repositories, what is available across that, right? Each one cannot create their own kind of repository. Then it becomes a bit hard for the DevOps team to really put the right things in the right place, right? So what we did first is we came up with an consistent repo creation policies. We kind of automated the way how anyone can create a new repository, right? And prior to doing this, let's say if I am part of team A, for example, I'll go ahead and start with my microservice, maybe a Spring Boot-based microservice from a Spring Boot starter template or whatever. I'll add all the files I need it. I push it into version control, and then they kind of tell, hey, you know what, my microservice is ready. And DevOps said, can you get the build pipelines and everything ready? Right? That's how it started with maybe a year and a half back or so. Right? And then DevOps team will start looking at, okay, what is the framework needed and blah, 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 everything. And they kind of create the build pipeline files, and then we push this into the same repository, and then things started working. But this was not sustainable. Right? For one team, you can do this. If 10 teams are doing the same thing, it's not going to work. And if the number of microservices increase, this problem will compound more, right? That is where we wanted to we bring in a consistency. So what we did is we created like a scaffolding we did, and then we created an entire repository in a common this one in GitHub, basically. And then what we also did is, maybe it's in the coming slides. So there is a small GitHub action we created. So just go ahead and click on that particular action and provide your repository name and what kind of connectivity you want it, and it just creates it in maybe a few seconds, right? And that has all the things in it. Let's say if it's an Kafka consumer, for example, it needs connectivity configurations to Kafka. If it's an microservice that's connecting to database, for example, like Cassandra, it needs some connectivity connection strings to the Cassandra, right? We kind of templatize all of those and then put in a repository. So people just need to click some of these boxes and then say, you know what, I want this microservice. Then immediately in a few seconds, it will be ready. And once it is ready, again, you also have the other CI/CD pipeline run, which I'll talk about next, right? That is one part is repo creation. And again, on the policies. So have you guys faced a scenario where somebody in the team would have created a repository with his own access, and then when he's on leave, nobody has access to the repository, and we can't do anything, and we are stalled? Have you guys faced that scenario? There is a repository, that is good. Step one, version control, yes. But who has access to the version control? Nobody defined that, so I don't have it, right? You would have seen that, right? That is where, again, the repo policies would help us. So what we already did is we created teams, different teams, like who should be the moderators. Now, let's say moderators is nothing but who can approve the PRs and merge the PRs. And who are like the readers, who needs to have a reader access into that repository, who needs to have write access to the repository. All these can be put in policies, and then we had created. So whenever a new repository is created out of this automation, all these are automatically set up. So there is no ping pong between, hey, you know what, he created it, he's not in today, so I can't really work on that bug. Right? So everyone has access with the right level of access, whatever is needed for them. That's where this consistent repo policies helped us. And then branching strategy. That's a very debatable topic, and that itself can go on for us together. So we use a Git flow-based branching strategy depending on the need what we had, like the kind of release trains what we wanted to follow. We thought that fits the bill, so we used that. I'll talk about it in a little bit detail in the next slide. And also, we had put some of these branch protection and deployment rules. So let's say if a main branch is when you will deploy it into any of your production environments. If it's a release branch is when we'll deploy into maybe QA environments and higher environments, etc., right? If it's a dev branch, the dev branch code goes only into dev environment. So again, both of these goes hand in hand. Depending on the branching strategy, your branching protection rules and the deployment strategy also will be linked. And then, of course, code reviews. So we use GitHub as a tool. So there's something called code owners that ensures every PR is assigned with the right owners, right? Otherwise, that's another problem. So maybe I'm a friend of my friend, so I'll just ask him add him as a PR. He just merges it, and then it just sneaks in, right? So we don't want to do that, right? So we want to ensure the proper code reviews are in place, so the right people are doing the right reviews. So add them as code owners so that you'll be able to figure out who is the right owner of that particular code, and then they'll get the PR reviews, etc. And of course, there are, depending on the branching strategy, you might need to do some down merges. So that's what we've also automated. Now, this is a bit of a branching strategy kind of a picture. So we have this master develop and release branches. So release is where every release happens. So basically, develop is your development branch. So developers can start creating multiple feature branches, as you can see here, feature 1.2, 2.2, etc. They'll start creating feature branches. They'll keep working on that. Merge it into develop branch, and whenever, let's say, at the end of the sprint, we think that, okay, this particular feature is complete, and we want to release it into production, or we want to take it to higher environments, then we'll cut out a release branch, and then we start promoting the release branch into further environments, and that release branch is what is getting pushed into prod. The reason why we had to do this is, okay, somebody's taking a picture and asking me to move down. Okay. So the reason we have to do this is to enable multiple releases to work in parallel. If you don't have such scenarios, you don't have to really go this route. You can have a simple main branch or master branch, and then feature branches, and keep everything, merge everything into that, and then you can start deploying them, okay? So this is purely based on your need, and this kind of helped us. So we had a couple of teams working on like a release 1, and then a couple of teams working on release 1.0 or 1.1, etc. So we were able to manage both of them in parallel. So that's why we had to resort to this particular branching strategy. And finally, once it's merged into the production, it is stabilized, then we'll merge that into master branch. So at any point of time, your master or main branch should be the replica of what is there in the production. Yeah? And with microservices, this could become very complex because the way how you tag your release is also different, right? Maybe one microservice could have 3 different releases going on. Maybe other microservice could have lesser. So everything, what I'm talking is at a repo level. So don't think at as a solution level as a whole, right? One solution could have multiple microservices inbuilt, right? So microservice A could be in version 1, B could be in version 1.1, C could be in 2.0, etc. So it depends on that. So all these are scoped to an individual repository. Yeah? Are you guys with me? Is it getting confused? Okay? I think the front guys are pretty good. They're always nodding. How about the backbenchers? Are you able to understand? Great. So yeah, this is I always keep referring to this particular link. I mean, the deck will be shared, so you guys can take a look at the blog post as well. And that's a branching strategy. And the version control for the tools, what we used, GitHub is our version control system. So that's where most of our things done. All the source code is hosted there. And we're using GitHub Actions to do the repo creation and repo policies, etc. A lot of people understand GitHub Actions as one of the CI/CD tool alone. So it also does a lot of things. So we're using that for repo creation, applying the repo policies, etc. And for scaffolding, what I call, we use a tool called EOMan. How many of you have heard about it? EOMan, EO. You say EO and then it will just create it, right? So that is what we are using. We've created a EOMan-based template, and then we created it, and then a GitHub action you trigger. It runs a EOMan generator, generate a microservice, and then give it, right? So it's just a matter of a few seconds. So, and this is the only slide where I have called out the tools explicitly. That's why I said I can, for the tools people, this is the only thing you can expect. And next is continuous integration, right? So what are the steps? Typically, all these are the steps that runs, right? You need to compile your code, run your unit tests, and then SonarQube, and then some of these Polaris, Black Duck, run a component test, Docker build, blah, 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 right? So if you look at it, these two, SonarQube and Polaris, are static code scans. Sonar is more for your code smells and other things, right? What is your code complexity? What's your cyclomatic complexity in your code? Have you written a very complex code? Have you written a maintainable code? Have you written a readable code? Are there code comments in it, etc., right? All these will be captured by your Sonar. And then we use, these are some licensed tools like Polaris and Black Duck. They are for running security scans. So Polaris is a SAS tool, SAST, Static Application Security Testing Tool. That means what if you have committed some of your secrets in the repository, or what if you have a leak or something in your code, right? It kind of understands those. And then Black Duck is more of a software composition analysis tool. So for example, if you are using a .NET, you might refer a lot of NuGet packages. If you are using a Java Spring Boot-based application, you might refer a lot of jars in your application, right, as part of your Maven dependencies. So what if some of those dependencies have any vulnerabilities? Maybe you are clean with your code. That's where the Polaris would say. But what if the dependencies have any vulnerabilities in it, right? So how do you identify it? That's where these scans would help. So we're bringing in the security is where we kind of call it as DevSecOps here, right? Security is now no more an afterthought now. We have baked in the security scans as part of every commits now. So as soon as someone adds a new dependency in the code, a library, then this Black Duck will tell whether the library is really secure or not. If somebody is adding a new piece of code or a new piece of functionality, Polaris and Sonar will tell us whether the proper, whatever the proper code smell is there or any security means are taken care or not, right? And everything is done. Component test is nothing but an automation test. So since it's more of an APIs, we have an automation test in place that runs the entire test and figure out if the functionality of the API is working really fine or not, right? And then we do a Docker build, and Trivy is another tool which we use to do a container image scanning. So once you build an image, right? See, what we have done so far till here is it's all in our control, right? We have the code and we have the whatever the jars and everything we have scanned. But when you build a Docker image, what we do, we use a base image, right? Use something called maybe from Ubuntu whatever version or from .NET version or from Java version, right? So what if those base packages have any of vulnerabilities? That's when we use something called Trivy that will help us in scanning those images. Once the Docker images are built, it scans that, and then it says whether it is, are there any vulnerabilities or not. If there are any vulnerabilities in any of these, the build will be broken, and team needs to really fix it up and then move forward. And once it's done, yeah, we just push it into the Azure Container Registry. And as of now, we are using Azure DevOps pipeline as a code. The pipeline YAML is what we use, and then we have done all of this in an automated fashion. And another important thing to note here is, again, all these need to be consistent across different teams, right? Different microservices, for example. If there are 10 microservices, all the 10 builds need to run this in the right order, in the right fashion. And we don't want anyone to also tweak it. And if I want to introduce any new testing in between, or any new scans in between, or if I want to change Trivy with another scanning tool, for example, right? How do we do that, right? That is where what we did is we kind of templatized all of these and put it in a common place. And individual microservices will just refer these templates so that they don't have to worry about what are the different tools are being used. They just need to know what are steps that needs to be included in that particular microservice. And as a central team, we'll just, let's say, tomorrow I'm replacing this with something else. We'll just modify the template, and all the microservices will get that change in a central fashion. If you don't do that, you need to go, let's say, 10 or 20 repositories, go to 20 repositories, and then go and modify each of these steps in it. Right? That's how you can try and optimize some of these activities. Yeah. And then, of course, once you have CI, then CD, right? So we had created some of these environments like Dev, QA, UAT, SPT, pre-prod, and everything. And in each of these environments, we had some of these automation tests, like a post-deployment automation, right? I didn't put anything for UAT because obviously our business just wanted to see and then test them manually, so we had to do that. Otherwise, in all the things, we have some of these, the automation tests in place. So that helps in understanding any issues immediately after deployment, right? Otherwise, you'll have to wait for somebody to, the manual person to come and then log in and then test and other things. So we get faster feedback as well. And as of now, these are all done using Azure DevOps release pipelines. Okay, so far what we've talked about is CI and CD part, right? How much time I have? It's 12:20, okay. So just shifting gear a little bit. Now I also talked about Kubernetes as our deployment target, right? So now how do you deploy all these microservices in a consistent fashion to Kubernetes, right? Hey, you guys, how many of you are Mac users? Mac? Okay. Do you guys know Brew? Not the brewery Brew. Brew as a package manager. Any Windows guys? You guys heard about something called Chocolatey? Yeah? What do? They're like package managers, right? That helps in packaging things together and then deploying it. If you want to install whatever terminal or anything, you just use Brew and then install it. If you want any Python, you use Brew and then install it on a Mac, or Chocolatey in a Windows, right? So like that, we also have something called a Helm chart for Kubernetes. How many of you have heard of Helm? Excellent. A lot of people know about it, right? So Helm is what we're also using here. So what we've done is we created a common chart which has all those bells and whistles what we want to be going into every deployment. So you can define what is the resource that is need to be allocated for every microservice, and what are the other, the liveness probes, readiness probes, and a lot of other factors. Everything is baked into a Helm chart, and that's centrally controlled. So individual teams don't need to worry about what is there. All they have is their own code in their repository, and then everything's taken care as part of the CI pipeline, right? And secrets, how do you handle secrets? HashiCorp Vault. Did someone read the slide? Yeah? You read the slide? HashiCorp Vault. Okay, excellent. Yeah, that's exactly what we're also using. Any other options? Has anyone explored any other options to inject the
Azure
secrets?
Key Vaults. Azure Key Vaults.
Sorry, from where is the voice? I can't see. Okay, Azure Key Vault, okay. And then? App configuration. Azure App Config. Okay. That's not purely for a secret per se, but yeah, it's more for an application configuration related stuff. So yeah. So here also we use HashiCorp Vault. So I think now recently we have this workload identity federation in Azure AD, right? With that you can directly assign a workload identity for your pods running in your Kubernetes, and then you can directly retrieve things from the Key Vault, etc. Right? When we started, we didn't have that, so we used HashiCorp Vault. So every time when a pod comes up, the secrets are injected into it. So we don't write the secrets into a Kubernetes secret or anywhere else. It's fully secure, and then whenever the secret changes, you just need to update in the vault and restart the pods in a rolling out fashion, then all of them would get the secrets into it. So that way nobody gets access to see the secrets as well. This vault is all protected again by an AD-based access control. And HPA we have used for auto-scaling. HPA is nothing but horizontal pod auto-scaler. Depending on your request, traffic requests ups and downs, your number of pods can go up and down. So which is what we've done using HPS here. And yeah, we also have some of the on-demand configuration deployments. So have you guys heard of something called config maps if you're working with Kubernetes? That's the default way to manage your configurations, right? So if there are any configuration changes that need to be pushed into Kubernetes, One of the ways is doing this. There are multiple other ways to do it. So what we've done is we've created some of these on-demand pipelines to perform this configuration so that you don't have to really do the entire rebuild activity. The CI part, what I showed, it runs a lot of steps, right? Obviously, it takes minimum 15 to 20 minutes. But for a config change, let's say, for example, you want to increase the timeout value from maybe 30 seconds to 50 seconds for a dependent service. You don't have to wait for 20 minutes to push that change, right? So just have some on-demand pipeline. So it just pushes only the config maps into the Kubernetes and restarts the pods. So automatically, within the next few minutes, you will have those changes in place. And blue-green is under deployment strategy. How many of you have heard blue-green? All of you know about it, right? Yeah, so you have two versions. You deploy into one would be active, one would be inactive. Deploy into one, and then live will be running in this. Once you deploy into inactive, just test all your changes in inactive, and then you can swap them, right? That way, you can also do a zero downtime deployments, and also you can ensure the changes are properly tested before actually going live. So we followed that. And also, we have set up some of these clusters with disaster recovery in mind. Let's say, like I said, we are using AKS, right? So if AKS in one region goes down, how do I bring up the new cluster in another region, right? So we didn't want to wait for the cluster to come up, so we kind of went ahead with an active passive setup. That means there will be another cluster that will be up and running, but the workloads will not be running there. So they will be like scaled down to 0, and then whenever there is any DR activity needs to be done, we kind of bring up the ones there. Yeah. And yeah, another thing is infrastructure as code. So that's about mostly on the application side of it, on the CI/CD part, and how do we deploy into Kubernetes, right? And I'm rushing through a little bit in the lack of time, and we can always catch up post the session as well. Yeah. And infrastructure as a code, we are using Terraform as well. So we've created central components like module stacks and modules. So we use those modules into different repositories wherever needed, and then we create this infrastructure. Let's say microservice A needs maybe a key vault access, a storage account access, and a SQL access. We've got commonly created modules for storage account, SQL, and then whatever, the key vault, etc. Right? We just use that in that particular repository, and then bring up that particular stack. Then it is available in the environment. Also, if you look at the environments I showed, we had multiple, like Dev, QA, SIT, UAT, SPT, so many things, right? So it is very, very important to have an infrastructure as a code in place. Otherwise, imagine someone going to portal or using something to click and create all these things, right? Which is not sustainable and which is not recommended also. And yeah, so we do use Azure DevOps pipelines to run these things. And isolation is very important. This we have done to apply the principle of least privilege, right? In the lower environments, you can try and have access or better access for your developers. But in higher environments, they all need to be restricted, right? If you are doing via manually anything else, you can't achieve that, right? So this is all done via automation. We also have policies applied. That means in the lower environments, there's a subscription that's created on lower environment that will have your contributor access for any of you who are part of that particular team. And you can go ahead and either modify or alter the resources there. But the moment it's a higher environment, it's only reader access is enabled there. So nobody can really go ahead and tamper anything with your existing resources. And yeah, that's what environment-specific access controls. And then break glass setup is nothing but an privileged identity management. How many of you have heard of this word? PIM. PIM is there, right? In Azure, there's something called privileged identity management. So with that, you can elevate your access. Like I said, let's say I'm assigned a reader access on my production subscription. Right? If I want to elevate my access to contributor to troubleshoot any of the production issues or so, then I should be able to do that. So you can elevate your access from reader to contributor, and you can define what duration you want it. You need it for 1 hour, 2 hours, 5 hours, 10 hours, whatever, and then you can do that, which is exactly what we have done to ensure that as well. And finally, this is another important aspect which we are trying to do now. So when we started, basically we had a common repository where we had all the infrastructure code in place, but then as the number of microservices grow, then the stack will become too huge, right? And Terraform, the way it works is every time you add a new piece of code, it goes and checks against what is the current state and what is the desired state, right? The more the resources you add, your evaluation time, and then the chances of affecting the other resources could be more. So it's recommended to put like one infrastructure stack per microservice. So the idea is you go to a single GitHub repository, you can find your infrastructure as a folder or so, and then have your infrastructure in it. And then you have your documentation. If at all you're getting a documentation, you have a documentation in the same folder. And then you can also have your source code, your unit test, everything in the same folder. So if anyone newly joining your team also, all they need to know is just go to this repository and then look for this microservice, right? They don't have to run around multiple repositories to understand what is present where, etc. Yeah. And yeah, so that's something about the infrastructure as code. And monitoring, yeah, we do have enabled Azure IaaS or PaaS monitoring. We do have dashboards created on Azure monitors itself, depending using the Azure monitors, and we also use Datadog as a tool to push some of these metrics. So these are some of the different monitoring we need to do. Application performance monitoring, that's very, very important to understand the performance and what is the bottleneck, right? Let's say our business users say that we want to, our microservice or the application should be responding within sub-second response, for example, right? Or maybe 100 milliseconds response. How do you understand where in the execution cycle there is a delay, and which part is taking more time to execute, and it's contributing to not meeting the SLA. Okay, that's where the APM metrics are needed. So if you're using SDKs, I think we also had a booth from Site 24/7 here, right? So there are SDKs available, which if you inject in your code, that will help us understand that. Or there are also cloud-native tools which are available, which can also help doing it, right? So we use OpenTelemetry as a format in which we send the application matrices. So with that, you can have your collector on the other side, and then that brings up the dashboards and everything. So yeah, another part is alerts. We have integrated with alerts with the teams. So anything happens in the Azure, let's say if an Azure SQL DB storage is growing high, or if your CPU utilization is growing high, then we automatically get an alert into a Teams channel. So that way, at least whoever is in the support can monitor it, and then they can react to it in a much faster way. So alerts and everything is important. We also use ServiceNow as our ITSM tool. So if there are any high incidents are needed, then we'll kind of push into that ServiceNow as well. Last part is SLI, SLO. Has anyone heard about it? Okay, service level indicators and objectives, right? We'll talk about it just after in the next slide, right? And so some of our learnings here, right? So first thing is, to be honest, the branching strategy. That get a lot of confusion with the developers. Not everyone understood what branch to be created when, and at what point of time that branch dies, and when a new branch should be created, and from where a new branch should be created, right? All these were some of the challenges, and which is very, very important, because the devs, if they don't know from where they're creating a branch and then pushing it, then that means a lot of disconnect would be happening between what is there in the production and what they have in the local also, right? So ensure whatever the strategies are being adopted, ensure all of the team members are clear on it, when they should merge it, and when they should delete the feature branches. All those things need to be taken care of appropriately. And then addressing security vulnerabilities. So though we had put in all of those pipelines and everything in place, in practical or in principle that works, but in practice it might not 100% work, right? Sometimes we might take a lot of time to fix some of the vulnerabilities. So just to enable some of these business functionalities, we might need to turn off some of these checks, and then we need to move forward, which is very practical everywhere. The goal is to move away from it. That's why we need more secure by design kind of an mindset, and then we need to understand those secure by design principles. Once you start doing that, then it will become a lot easy for us to start addressing those vulnerabilities, right? And then we had put, because we had multiple environments, and depending on the team size and other things, we had put some of these approvals on each and every release. Let's say if a particular release needs to go into a pre-prod environment, there were quite a few approvers, like maybe DevOps team, and then the release, whoever is handling that particular release, teams manager, and the QA team, etc., right? Initially, it was fine because everyone was, first release is always slowest one, right? People will just, okay, they'll take their time and do it. But then the moment you want to do subsequent releases, that became like kind of a blocker for us. So we're now trying to see how we can automate as much as possible, right? That's one of the things. And yeah, environment provisioning, again, the reason why I called it out is, though we have put all these in the Terraform and everything, when you try and run these Terraform, we did face some issues. That was also because of the reason why I quoted, right, or what I quoted, right? We had put all of this stack in a single repository initially, so it will say like 50 resources to be modified, and 30 to be updated, and 10 to be created. So now it becomes a bit tedious for anyone to go and review that and then understand what is really what, right? So that's kind of added more time for us to complete the Terraform part. And yeah, monitoring and troubleshooting. So though you have all the alerts, how many of you respond to any alerts? If you get anything in Teams channel, you go and say, hey, I'm looking into this alert. Good, man. You guys are very good. Right? So so most of the time, like, we have to go and again do a postmortem kind of thing. Hey, you know what? These alerts came in the last 2-3 days. They didn't even look into it. That's a practical that happens, right? So yeah, so that's one area we are trying to again improvise as well. And of course, yeah, so I think this is something which Madan also talked in his keynote, right? So now we put in all these things. How do you measure whether really all these are working fine or not, right? That is where all these 4 metrics comes. Deployment frequency, how frequently we're able to deploy things. Let's say I committed a code to GitHub today, which is October 21st. If this is going in October 21st, 2023, that's not the good thing to be, right? So we need to understand how fast a particular commit that is made into Git is moved into any of your environments. That's a deployment frequency. And then lead time to change, how long it is going to take to make that. Actually, what I explained is for the lead time to change. When I commit now and then how long it is taking to push it into production. Deployment frequency is how frequently you are deploying it. Is it daily deployment, weekly deployment, monthly deployments, etc. And change failure rate, how many deployments you are putting are breaking the build or breaking into functionalities, etc. And time to restore. This is one of the key things. And after we put into production, if any incident comes, how long we are taking. Has anyone resolved incident in less than an hour? In 1 hour? Excellent. Is it a P1? Okay, great. So that is another metric we need to capture it. We say, okay, we are pushing all the logs, metrics, and everything into the monitoring tool, but are we equipped to go and search those in the right fashion? Are we able to understand what's really happening there? How do you narrow down to an issue? That's more important, right? That is when this time to restore service will come up. Half the time, once the incident comes in, people realize they don't have access to that system, right? When we say, go and look into this, they say, no, I don't have access to the system, right? So those all contribute to your this particular metric, right? So what's our way forward? Okay, yeah, I'm about to complete. So currently we are like following DevOps, and I'm sure all of you have heard about SRE, right? What's SRE? Excellent. Everyone Googled it before coming to this session? Site reliability engineering or service reliability engineering, right? So then what is the difference between DevOps and SRE? Any thoughts? Any take? Okay, sorry, one by one. I think someone's saying DevOps is a cultural aspect and SRE is an engineering aspect.
No, it deals more of engineering part of the operations, and DevOps is more of culture adaptations with development as well as the organizational perspectives.
Okay.
So
Partly
anyway, it go in hand with the DevOps and SRE, but it definitely, no, the SRE is not a DevOps 2.0.
Yes, absolutely. That's correct. Any other questions? Scale, okay. Yeah, partly right, all right. So I just have one slide to talk about these differences, and especially the metrics, what differentiates both of these, right? See, DevOps, when you say that's more on your SDLC, right? From idea to production, how fast you're able to do, what are the practices you're able to inculcate in it, right? That is what is all about DevOps side. And the metrics, what we just saw, these are the metrics that can tell, or that can talk about the maturity of the DevOps practices, right? But when we talk about SRE, it's all about, as you rightly said, site reliability engineering. That means how reliable our services are and how it is behaving after we put it into production, etc. Right? It's morely on production and beyond. Do we have the right monitors in place? Do we have the right alerts in place, etc. Right? And there is something called golden signals if we talk about SRE. So these are some of the 4 signals. What is the traffic? What is the traffic my application is able to handle? Is it 1x, 2x, 3x, and when it will break, etc. Right? That's what you will understand as the traffic. And latency, and how is the latency of my application? That is it in sub-seconds. When the error comes, are they coming up fast? Or when the success response comes, are they coming fast? Right? How do you differentiate both of this? When you understand the latency, are you going to consider all of them, the error response as well and the success response as well? A lot of things goes into picture under the latency part. And errors is also how many errors are coming up from your service, and what qualifies an error in fact. Right? Is it just a 500 or an error, or 200 with some wrong data is also an error? Right? So how do you identify all of those aspects? And finally, saturation is when it can break, right? So let's say with the rate of, for example, we have provisioned an Azure DB with maybe 200 GB storage. And if the data volume growth is like 10 GB per day, then we can say that in 20 days, maybe we'll just run out of this, right? That's a simple math. But let's say if your application is consuming maybe like 80% of CPU for 3 to 4 hours in a day, which is the peak timing, right? Then how do you understand when it can break us, right? What is saturation? When it can get fully utilized? If that 4-hour becomes an 8-hour window, can our system withstand? Right? Some of those things is what you will try to put in there. So I'm also learning some of these and then trying to see how we can start applying all of these into it so that we have DevOps in place that helps us in taking it to production, but post that, how are we measuring other things, other aspects of it, right? Thank you.